Yes, welcome for our lesson 4 of electrochemistry. In the previous lesson, we were introduced to what we call electrolytic conductivity. We saw an expression leading or that gives us electrolytic conductivity. We saw the definitions. We actually gave 2 definitions in that video where we said electrolytic conductivity can be defined as the reciprocal of resistivity. In that case, the spelling of the word reciprocal is very important. And then we also saw that looking at it as specific conductance, we would look at the length and the area being unit. And once in this formula, the length and the area are unit, then electrolytic conductivity is conductance. And so we said it could be defined as the conductance of a solution of an electrolyte which is placed between 2 parallel electrodes of unit distance apart, that means 1 meter or 1 centimeter apart, and unit cross-section area each. That would mean 1 meter squared or 1 centimeter squared at a given temperature. That could be another good definition of electrolytic conductivity. And then we say in the expression, it is conductancy multiplied by cell constant. Now, we had moved on to examples and we left this example that we are going to start with and then see more other examples on the calculations involving electrolytic conductivity. In this example, we have been given a cell with an electrolyte that is 0.02 molar. And the cell has a resistance of 0.357 ohms, and this cell has a cell constant of 1.5 meters or per meter. And we are required to calculate the electrolytic conductivity of the cell. And I had said that in such questions, let me get my calculator here, in such questions where there is a formula, and then the first thing is to state the formula. And after stating the formula, then we do the substitution. So, in the formula, what is R? R is the resistance, and L over A is the cell constant. So we simply now say that our K is equal to 1 over, that is 0.357 times the whole of the length over area is called a cell constant. And so this position is taken by 1.5. So this time is 1.5. And we substitute or we press our calculator. In the calculator we have 1.5. We are dividing by 0.357. And I'm getting 4.2. This is 4.202. And then we put the units. What are the units of K? The units of K, we say, these are going to be per ohm, per watt. Now, the units of cell constant is per meter. So we don't give in per centimeter, because if I was substituting here, this one would be per meter for the cell constant over the ohm. So the ohm going up becomes per ohm and then per meter as our units. Now, someone will ask, what was the concentration before? Normally, when we are putting electrodes, we know their concentration. So concentration was not important in this calculation because in the formula there is no way we will substitute. Possibly, it would be used to do other calculations in the next part if it was there. So concentration in this case is not very important. But we can have another question. Another question is saying the resistance of potassium chloride solution. Another question, number 2, the resistance of potassium chloride solution. Potassium chloride solution is 361. 361. This is not resistance, the resistivity. Sorry. Resistivity. Resistivity of potassium chloride solution is 361 ohm centimeter. Ohm centimeter. And conductivity of a cell, conductivity of a cell having potassium chloride solution, such a solution, the cell having such a solution was found to have a resistance of 550 ohms. 550 ohms. So the resistance of potassium chloride solution is 361 ohm centimeters. And the conductivity of a cell having such a solution was found to have a resistance of 550 ohms. And then the questions are coming here. They're saying Roman 1, the first question, Roman 1, they want us to calculate the cell constant. Calculate Roman 1, the cell constant. Let us calculate the cell constant. And then in Roman 2, they're saying if the same cell was filled with zinc sulfate, if the same cell was filled with zinc sulfate solution, which had a resistance of 72 ohms. Can we determine the electrolytic conductivity? Can we determine the electrolytic conductivity? Can we determine the electrolytic conductivity of the zinc sulfate solution? So we have such a question building up quite a story. We are beginning with a cell having potassium chloride solution, and its resistivity was measured to be 361 per ohm centimeters. Conductivity of the cell having such a solution was found to have a resistance of 550. Can you calculate the cell constant? So let's look at the solution. Now, as I said, since there is a formula, the first thing you do, look at the formula. The formula is that the conductivity is equal to 1 over R times L over A. 1 over 1 over R times L over A. And this expression should help us to get whatever we want. Now, the first question in Roman 1, they want us to get what we call the cell constant. What's the cell constant? Cell constant is the ratio. Cell constant is normally defined as the ratio of length between electrodes to cross-section area of each electrode. So the ratio. Now this is the cell constant. Now if this is the cell constant, they have given us resistivity, not resistance. But they have also given us resistance. Now what is resistivity? We say K is the reciprocal of resistivity. That means where there is K, since we have been provided with resistivity, we shall say 1 over rho is equal to 1 over R times L over A. Such that we deal with what is in the equation. So we can now substitute and make the cell constant the subject. So in this case, I can even substitute length over area as cell constant. So what is cell constant now? Cell constant according to that expression would be R over rho. Resistance over R, making cell constant the subject here by cross multiplying. And then that would give us, we substitute, the resistance was given to us as 500, and the resistivity was given to us as 361. And for purposes of the units, you can see that this was ohm, but this one is ohm centimeter. So when we divide, if we divide 550 divided by 361, we get a resistance of 1, we get a cell constant of 1.5. 1.524. And these will cancel and we get per centimeter, which is the units of cell constant. Now, from Roman 1, they go ahead and they ask that if the same cell, now every time we see the word, the same cell, they are simply referring to the construction of the cell. What is constant in this same cell? Because we are going to change the electrolyte. But what is constant and why they are saying the same cell is the distance between the electrodes and the cross-section area of each electrode. So the same cell simply means the cell constant is the same. So here, by saying if the same cell, then they are saying similar cell constant was filled with zinc sulfate solution. It had a resistance of 72. Determine the electrolytic conductivity of zinc sulfate solution. So we can rewrite again the formula that electrolytic conductivity K is the conductancy, which is 1 over R, times the cell constant L over A. And therefore K would be 1 over 72, which is our new resistance, because we have changed the electrolyte, times the cell constant 1.524 that we have just obtained. And this would give us that value divided by 72, giving us the electrolytic conductivity as, I'm getting 0.021. 0.021. And what are the units? The units for cell constant is per centimeter, but the units for resistance is ohm. So when you write this one on the same line, then it will be per ohm per centimeter, which are the units of conductivity. Or someone could say S, which means per ohm, and then per centimeter. So this is how we approach these questions of conductivity. We can have one more quick one, and then we look at a different concept. Now, in the next one, we are saying that a conductivity cell with the electrode is 2 centimeter. Conductivity cell. A conductivity cell with electrodes of 2 centimeter squared area and 1 centimeter apart and 1 centimeter apart, has a resistance of 7.25 ohms when filled with 5%. When filled with 5% potassium chloride solution. When filled with 5% potassium chloride solution. And the first question is saying, Roman 1, can you calculate the cell constant? Can you calculate the cell constant? What do we mean by cell constant? Cell constant is the ratio of the length over area. So cell constant is length over area, the ratio. And therefore, if the area is known and the distance is known, then we can always get cell constant as 0.5. 1 over 2. And the units will be per centimeter. So we can get cell constant direct from the values given. Now, for that, they are saying, Roman 2, can you calculate the conductivity of potassium chloride solution? Can we calculate the conductivity? Yes, now that we know the resistance and we know the cell constant, very possible. Conductivity K, this is now Roman 2, should equal to the conductance times the cell constant L over A. Now this is known. This is also known the resistance. So this is 1 over 7.25 times the cell constant, which is 0.5. And that would give us 0.5 would divide by 7.25, and it will give us the electrolytic conductivity as 0.06. This is 87. Now this is per ohm per centimeter. And now we have that other question. If the same cell was filled with potassium chloride solution with a resistivity of 361, what would be the resistance? If the same cell, now part B, if the same cell was filled with potassium sulfate solution with a resistivity of 361 per ohm centimeter, can you calculate the resistance of the solution. Now, if the same cell, we said once we see the word same cell, then the meaning, the conductance is the same. Now, they are also giving us resistivity. Resistivity is only related to conductivity. So, conductivity K is the reciprocal of resistivity and is equal to cell constant times conductance, 1 over R times L over A. So, the unknown here is R. And so we can substitute easily and get the answer, since we know that 1 over 361 should equal to 1 over the unknown times the cell constant that we got earlier as 0.5. And so resistance can easily be obtained. Using our calculator, you can compute and get the answer. The units will be ohms, since it is resistance. So in this lesson, we have looked at as many examples as can. In the next lesson, we shall be discussing the factors that affect electrolytic conductivity. See you there.